Kæmper vänner. Dem kæmper vänner med det USA. Ja, okay. Can you guys hear me okay? Cool. Cool, cool, cool. Jo. Ich hab Wasser hier. Am I supposed to start, Chris, or do we wait for more people? Okay. Okay, okay. I think most people are here. Hello, hello, hello to this talk, BoxLang versus the world. I just want to give people the right impression of what's going to happen here, right? So this is not a heavy technical talk on BoxLang, because you just spent like 45 minutes with Brad, and then you spent like 45 minutes with Louis before, and I don't need to repeat that whole experience, and they are much better in doing that anyway. What this talk is going to be about is a bit of a, I don't know, 30,000 feet view on BoxLang versus other languages, and what kind of the expectations are when you think about like what makes a language successful, right? Because we're looking at a new platform and a new language, like why would you want to invest your time into this, and why potentially not, right? So let's get started. My name is Kai. I have been doing CFML for a long, long, long time. I do a whole bunch of other things, mainly JVM technology. I do a lot of Python and Ruby these days, and I'm generally a fan of Unix-based infrastructure. You couldn't get me to touch Windows with a barge pole, basically. And apart from backend development, I also do Android using Kotlin and Flutter, and work on a bunch of SDKs for like mobile application platforms. The agenda for the next, I don't know, 35, 40 minutes or so is actually really simple. Let's have a look at BoxLang versus other languages and tech stacks. So that's the end of what, well, that's pretty much the gist of what we're going to do. And let's start with BoxLang. So BoxLang is pretty much, as you have learned today, a new language and a new language runtime from Ortus. Cool. The nice thing that makes it immediately applicable for a bunch of people here is it has both a tag and a scripting language and a very high degree of like compatibility with existing ColdFusion code. Maybe not 100%, and there are probably a bunch of edge cases and really quirky behaviors in existing servers, let it be Adobe ColdFusion or Lucy, that might not map exactly to BoxLang at this stage, but the idea is to have that compatibility, right? Dynamic language, optional type system, so you can actually use typing if you want to. Promoting a lot of really good modern Java interop using invoke dynamic. There's no Java reflection anymore. You can run it, or you have to run it on a modern JDK and a JVM, not on something like Java 8 or Java 11 anymore, which is frankly quite annoying in 2024 these days. You can actually use functional constructs like context-aware closures. There are pure functions and lambdas available. There's really good support for async, futures, tasks, and Louis is doing a talk about tasks specifically tomorrow, which is all built into the platform, right? So it's a very modern approach to software development, and it's not your ColdFusion from 10 or 15 years ago anymore. And that is a big thing, that item that I put on there now, right? Like even in the alpha and beta releases that I saw about 2 months ago, BoxLang had about 7 million% better tooling support than any existing CFML platform over the last 20 years. From day -60, basically, before it was even officially released. And that should be a reason alone why BoxLang seems to be really worthwhile looking into that, because they launch with an IDE, with a debugger, with a parser, with an abstract syntax tree tool, and a whole bunch of other things. And I'm like, cool, where is that stuff in other platforms? And the answer is, it doesn't exist to this extent. And it's small, lightweight, and very modular by design, obviously. And it is compatible with JSR 223, which basically means you can use it in a variety of other JVM contexts. So the contenders for this, look at other technology and other stacks are basically Java, Kotlin, CFML or classic CFML and CFScript, TypeScript, Ruby, and Python. And that's a very arbitrary choice, and I basically made that choice because A, they are popular, they kind of fit into the general things of what we're doing with CFML and BoxLang, for example, and this is pretty much what I use on a day-to-day basis. Kotlin, specifically, I use a lot in Android development, not that much on the back end. Ruby, I use a lot for scripting, cloud scripting, big Unix systems, and Python, I do a lot of data analysis in. So not all of these technologies I would use for web development personally, but they can be used for that purpose. So Java, really old technology from the 90s, OO language. It was basically built with the idea of platform independent, write once, run anywhere, Java applets on fridges, and all these crazy bizarre things. Java essentially is a statically typed language. It has really good memory management, automatic garbage collection that you can tweak, even though that is not really a Java feature, that's more a JVM feature, like a platform feature. It has a huge ecosystem, tons of libraries, tons of frameworks, for example, Spring and Hibernate as some common ones, but other things for various third-party technologies. Widely used for enterprise applications, Android app development, and server development. Then we have Kotlin. Came out of JetBrains around 2010 as an internal language spec. It's a statically typed language, essentially, that runs on the JVM as well. And I'm coming back to the history of Kotlin a little bit at a later stage. But it is fully interop with Java. So you can actually pretty much have projects with Java code, with Kotlin code, and you can call your classes and objects basically at runtime together quite easily. It has a better / more concise syntax than Java, much less boilerplate code. And it has really cool stuff like null safety, extension functions, also lambdas and pure functions that Java at the time didn't have. That's really important to see in the historical context, right? When Kotlin was designed, Java was basically on the level of Java 6, Java 7, Java 8, and it was like a very traditional OO language which had nothing of these modern things. Since 2018, it's officially supported by Google for Android app development, which is kind of cool, and we'll come back to that as well at a later point. It has a decent-sized ecosystem, continuously growing, but because it can interop with Java so easily, it means also that you can pretty much use any Java library in Kotlin if you really want to and have to. The adoption in backend or API development is slower than it has been in Android. But nevertheless, people are using it, and there are really great frameworks for Kotlin to build API platforms or to build like a web app driven by like a JavaScript framework or JavaScript frontend or something like that. Okay, then we have CFML, CFScript, and we can probably run over this quite quickly. Scripting language, used a lot for web backend development. Tag-based language, CFML. CFScript is the script-based syntax. We know all that. Has cool stuff like integration points with various databases that come kind of out of the box with the CFML servers that we have. And that's one of the benefits why people use ColdFusion or CFML, obviously. There's support for a lot of common web development tasks like sending an email, receiving emails, uploading stuff with FTP, dealing with images, processing stuff. it's all built into the language somehow. It supports kind of OO with CFCs and components. The whole setup of object orientation in classic Cold Fusion, and with that I mean like what came out of Adobe initially, is sort of a bolted-on approach, right? At some point there was a need for having a way to encapsulate things, so they came out with components. And components initially didn't even have inheritance, so that was bolted on, and abstract was bolted on, and interfaces were bolted on. And that means the language around components and OO in CFML is slightly inconsistent, and it doesn't feel like well designed from the start, because it wasn't. There is an existing ecosystem of libraries, which these days mostly live on ForgeBox, obviously. So it is convenient to develop in, because most of the things you don't find in the language are provided by third parties. But the ecosystem is obviously not even close as big as Node, for example. And I mean, the size of the Node ecosystem, or the Node and NPM ecosystem itself, is probably worthwhile its own discussion, because that has a whole pile of problems by itself. And then CFML is obviously used primarily in the Cold Fusion Lucy server environment. Let's have a look at TypeScript, which is essentially a superset of JavaScript, adding additional optional static typing if you want that. I personally think TypeScript is the only way anyone should write JavaScript code, but I accept that people have different opinions on that. It's a mix of OO and functional language paradigms, like JavaScript is as well. Essentially, TypeScript compiles down to JavaScript for execution in browsers, or in Node, or in Bun, or in any other potential Node-based or JavaScript-based runtime. It has, because of the typing and the fact that TypeScript is heavily driven by Microsoft as well, sort of much better tooling support, code completion, and like stuff like refactoring in IDEs than plain JavaScript. And that just comes from the fact that it is this superset of core JavaScript. You find it widely adopted pretty much everywhere. There's the whole idea of like full stack developers, obviously, people doing backend work in TypeScript or JavaScript and doing front-end work in TypeScript or JavaScript as well. I personally think around that full stack developer, that's a bit of a myth. Sure, you can hire someone who can do backend and front-end development. There are lots of people who are great in both, probably not, to be honest. And a lot of organizations fall for that myth of, we want to do everything in one technology, and we want to do basically everything in JavaScript because we only need to hire one person. And frankly, in most cases, that's bullshit. But yeah. And also, TypeScript makes it much easier to deal with issues and errors, because in plain old JavaScript, you can just catch stuff at runtime more or less, and here you can at least get stuff during development and compile time. Then we have Python. Python is probably the oldest of the languages, well, it actually is, yeah, that we're looking at here. Around since the 1990s. It's very high level, very easy to understand and easy to read language. It's interpreted, which at first glance seems like, oh, this is bad, this is slow, right? It's interpreted code. It doesn't have to be. When you look at like using Python in data science, for example, lots of stuff that is actually executed is compiled through versus available layers. So Python itself, when you run it in like your IDE, yeah, it's slower than Go or Rust, but you get other benefits from that, obviously. Again, object-oriented language supports procedural and functional concepts as well, and is dynamically typed, but has kind of a strong typing approach if you want to use it as well. Lots of emphasis has been put on code readability. So to a point where if you've never done Python and you try to get something going and you're using code indentation as you're used to it from JavaScript or CFML script, basically you will go mental because the compiler will not allow you to let anything go through, right? So white space indentation in Python is a means to structuring your programs. If you don't know that, it's kind of like really weird at the beginning. But if your indentations are not correct, Python will not run your project. It has a huge standard library, a huge ecosystem of third-party packages and libraries, and that was in the recent past mainly driven by AI and data science. So there is stuff like, I don't know, NumPy and Pandas, TensorFlow, PyTorch, and they all come out of this whole, we want to deal with big data movement. But there are frameworks for web development, like Django and Flask are the most common ones in the Python world as well. And because of its nature of being interpreted, a lot of people use it for rapid prototyping and rapid development. So it has a bit of a similar approach to certain things like CFML, for example, which we also can use for rapid prototyping and rapid development. And then the final one here is Ruby. Around since the mid-90s, dynamic, interpreted, and object-oriented. It's a scripting language. And they claim themselves that they have an elegant syntax, which they have, but it's probably also the most uncommon syntax of all these languages because it is elegant and different at the same time. It supports a whole bunch of different paradigms. You can do stuff procedurally, functionally, or classic object-oriented. There is obviously Ruby on Rails, or Rails, the most common web development framework in the world, most likely, that everyone has at least heard about. And lots of people use it for scripting, automation, and other application development beyond building a website or an API with it. So for example, I've never built any web application with Ruby. I use it for Bash, as a replacement for Bash scripting, because it gives me some more verbosity in what I want to build with scripts on servers. Okay, so that's a rough overview of what we're looking at. And what I want to do now, quickly, is run through 3 different cases and look at some sample code. And the samples I'm showing here are by no means the optimal or only way of solving a problem in these languages. They are a way, but I want to make a point, which we come to in a few minutes, that will be driven by these code samples. Let's start with arrays. So when we look at arrays, they pretty much exist in any language, right? And a Java array could be defined like this, and then you just iterate over the array, basically, in like a for loop. And one funny thing is, like, I totally forgot that you could define a Java array with curly braces, like following the C syntax. That was one of these weird things I rediscovered when I put together the slides. I was like, oh yeah, I can actually do that. That's kind of, yeah, totally forgot about that. But you see the idea, you declare something, list of numbers, then there's a for loop with some sort of a way to define a local variable for the loop, and there's some sort of an output, whatever. Kotlin is similar, right? So in this case here, we've got a value numbers, and this is just defined by using a function called int arrayof in this case. But again, the iteration is for loop, variable in something, output the thing. CFML tags, okay, an array, CF loop, index variable, output the thing. TypeScript. Slightly different syntax. We use const, and we define the array a little bit differently, and then you just console log the whole thing. So that works as well that way. Python, and that's the first case of the funny white space indentation. You define the array, and then you see like it says for num in numbers colon, and the indentation for the print is actually important. If this is not indented for like 4 characters, code will not run, basically. But coming back or comparing it to other languages, again, the construct is similar, right? We define an iterator, we loop over the thing, we output the thing. And then Ruby, and that's the slightly different one. In Ruby, you would traditionally use kind of what we call a member function in BoxLang or in CFML script, like in .each. And then this kind of the iterator is in horizontal bars this way. And the syntax is I have no idea why they came up with that syntax. I find it unusual. Other people would say elegant, but I mean, it's still readable, right? You look at the code and you get an idea of what this is doing. So first thing to notice is like arrays as like a fundamental construct of a language seem to work very similar in different languages. There's not a huge difference, right? Like if I was to say, I want to be as productive as possible when I'm coding, and my criteria would be how do I deal with arrays, it would would make no difference, basically. We can have a look at another structure, like structs or hash maps, for example, which are basically kind of untyped objects in a wider sense. When we look at that in Java, this is probably an overcomplicated example. So we can define a map, which is a hash map, put stuff into it, like ABC with some values, and then we're iterating over that hash map and output the value, and it will say something like A is 4, B is 5, C is chi, or something like that. In Kotlin, that is already much simpler. And the reason is because Kotlin was actually set up with the idea of making this Java boilerplate code much, much easier, right? So we see some actual improvement here where the language makes a common thing much easier and simpler to look at and to read. And they have this cool thing where you can actually iterate over the hash map with like a key value pair in a thing, and then you get both values out of that at once. CFML script, quite simple as well. We define a struct at the top, and then we just do a for key in map loop. And that could obviously also be done with a member function, for example, instead of a for loop. TypeScript, constant map up there. Looks very similar to CFML, and then we iterate over this with the for const key in map construct and console log it. Python, the only exciting thing is the indentation again, and also the fact that this for loop, when you loop over a structure or a map, or what's called a dictionary in Python, you can actually use key and value basically in one way in line 9. That you say like for key and value in the map, give me that kind of stuff. And you don't have to use a function to call to get me the value or something like that. And then Ruby, again, doing its own thing with the syntax. So the map is defined with arrows. That's a bit different. And when we iterate over the map, it has the horizontal bars for key and value. But from a conceptual point of view, very, very similar to Python, for example. OK, so again, structures and hash maps, you look at the language syntax and you realize, well, OK, they all work somewhat similar, right? If we're after productivity or after something super exciting new, it doesn't really make a big difference. Let's have a look at the idea of classes and objects. Next thing. So in Java, we've got a class person, for example, with a name and an age, and it has a constructor in lines 5 to 8. And then there's a function greet that just produces some output to the console, or wherever you want that. And then that class can be used with like creating a new person and calling the greet function. Quite straightforward. But you could argue that this already has a bunch of boilerplate code in the Java world. So you could make that more efficient if you wanted to. And that's one of the things, again, where Kotlin shines, for example, because Kotlin set out to make that more efficient. You don't need an explicit constructor. We define kind of the class fields as values pretty much in the class definition, and all we need to do is add the function. And they have that nice thing, I don't know if you notice, where you can say $name and $age. That's called string templates in Kotlin, which is actually very similar to how ColdFusion or CFML deals with strings, and which is one of the big benefits of using that language compared to like doing string addition, for example, in Java. And to be fair, you can do that in other ways in Java these days as well. You can make that more efficient. CFML script, we've got a component in this case with accessors, some properties with default values, and a function that is using kind of the string template idea, obviously, with the hashes in typical CFML code. And then it's using the new statement to get a new person, setting the name, setting the age, and calling the greet method. And again, this could be done differently and could be done a bit, less verbose and nicer. This is the first slide showing BoxLang. So I don't know if you noticed what the difference is. I'll just go back and forth and back and forth a few times. So the big difference is obviously in BoxLang it's called a class, which is really nice because that makes it consistent with the rest of the world. I wrote the greet function a bit differently, but what you can see is in this simple example, there's not a big difference between BoxLang code and classic CFML code. Again, this code could be done in a different way. It could be done without properties. There are tons of ways to write classes and components in both of these platforms to suit your style of doing it. I personally like the properties approach, but I know other people who don't see much value in that. I personally do. TypeScript, again, idea of a class, encapsulation, name, age. There's a constructor statement and a greet function, and then we just create the new person object and call the greet function. Similar approach, right? We always have a class, we have fields in the class, we have a function, and we instantiate it and call a method. Same in Python. Python has a bit of a funky syntax with this init thing, which is kind of a constructor, and it has a reference to self. That is kind of similar to this in CFML, but down there, the way how to call it is, again, very similar. And Ruby, also a bit of a funky syntax. There is this initialize construct that you use to provide a constructor, and they use this add syntax to refer to the local variable inside the class, which are these accessor things at the top. And then the greet function, again, is using kind of a string templating. But once again, very much similar, right? So the idea is always there is a construct to create a thing, then we instantiate that thing and we call a method. And obviously now, because we've seen this for 5 or 6 languages, it's true for every single language in the world. So we've proven that all the software languages are basically the same, which is not true, but it is fair to say that modern programming languages in general these days are quite similar, right? On this level of fundamental constructs, they share similarities. They share the same concept, and they share even the same syntax, depending on how you look at it. The typical ECMAScript curly braces languages, a for statement in these languages pretty much looks like a for statement in any other of these languages, more or less. The most exceptional ones are probably Ruby and Python, because they come from a different paradigm. And obviously CFML tags, because that's kind of somewhat weird compared to all these script-based languages anyway. So the question is, if on a syntax level, on the fundamentals, these languages are also similar, what is actually the difference? And what is the differentiator of why you would want to use something versus not using something? And it comes down to other things from my point of view. One of them is ecosystems. What kind of libraries are there? What kind of support is there for different platforms, for example? Personal preference. Some people just want to use one language, whatever that might be. It might be JavaScript, or it might be CFML, or it might be Python. They don't want to use anything else, and they want to solve all the problems that they have in their work or hobby development with that one tool. That is problematic. I can understand, though, why people fall for this kind of trap a little bit, because it is convenient, right? You know something, so you use it for everything. I mean, I've seen people who've pretty much written deployment systems in CFML tags because that was the only thing they know, basically, instead of using maybe a more appropriate technology. It works. Would I have done it that way? Hell no. No way, right? But, people do these things. Then there are organizational preferences, and they are usually driven by the ease of finding developers. Like, I can't find a Cold Fusion developer, or I can't find a whatever developer, right? ease of finding third-party libraries, and it refers back to ecosystems. You know, if I want to do, I don't know, say an integration with PayPal in my technology, and there is no PayPal library, I have two options. I write one, or I use maybe the Java one if I can, or I put my hands up in the air and I say like, this is all stupid, it's legacy, I can't even integrate with PayPal. So that plays a role when people choose technologies, basically, or when people move away from technologies as well. And then there is obviously the public perception, right? Like we know that people look at Cold Fusion and CFML and say like, this is old rubbish. Like, why are you using this? I hear that like every few weeks from people. Makes no sense because like I've built systems running billions of requests per month, basically on certain platforms, Coldbox, and they're super high performing, much better than the equivalents that someone else built on Node, for example. So the perception plays a role, unfortunately, so. And then there are other things like the peripheral features, for example, like availability of modern language features or alternative programming constructs, right? If you want to do something more functional with lambdas or pure functions, can you do that? If you want to use ideas like monads or closures, can you do that with your technology? So there's almost an expectation these days that if you go into a tech ecosystem, that you can do OO and functional, and that there are closures, and that there are pure functions. And if they are not there, that contributes to the negative public perception. And then there's obviously stuff like performance and deployability. So you want to have something that works well at runtime, and you want to have something that you can deploy into a bunch of different places, from your own server to cloud to whatever you can think of. But I think let's come back to that perception thing for a little bit. The perception is, as I said before, that CFML and anything that is related to Cold Fusion or CFML is old and almost rubbish compared to the new modern world of JavaScript. And a lot of that perception comes down to innovation or the perceived lack of innovation, right? So which now means like, where's the innovation in our ecosystem currently happening, right? And when you look at it, it almost solely comes out of Ortus and the Box team. And this is not meant to diss people who work on other projects, but that is the reality. You look at like frameworks, and you find like Coldbox and all the libraries around Coldbox, Testbox, Wirebox, Cagebox, you name it, are by far the most professional and most mature frameworks in the CFML ecosystem. And if having done work in Spring, not in Rails though, Coldbox can easily take on Spring from a functionality point of view if you want to build like a modern application using a modern approach. There are other frameworks, but they are, from my point of view and my experience, minor compared to the massive push that Coldbox has provided. Then there's CommandBox in containers, and both together have modernized and revolutionized the way how we actually think about Cold Fusion and how people develop locally and how people deploy things. I said before, I'm running a system with like more than 1 billion requests per month on CommandBox, right? And people ask me sometimes like, oh, you can use CommandBox in production? Sure you can, it's fine. It's a server and it's stable and it's quick. Then ForgeBox has become the place to go for modules and packages, right? And frankly, the Ortus people having been so nice and wrap up like ACF and Lucy and various JDKs so that actually developers can make that, or can have like an easy way to build and deploy stuff. And so it feels almost like BoxLang was or is the next logical step, right, in this train and push to innovate coming out of Ortus. And I should actually mention, I'm not paid by Ortus, and I'm not, legally or company-wise associated with them. It is just a fact when you look at the ecosystem that we currently live in, that all the new and cool stuff, or the vast majority at least, comes from Lewis's team. So when you realize that, the next question is like, why is BoxLang worth a look, from my point of view? And it has a bunch of reasons. Some of them are technical, and some of them are like, ecosystem community related. So one is obviously it's tiny and I can deploy it in a plethora of environments, from my own server to the cloud, to AWS Lambdas, maybe to Google Cloud Functions at some point, and some others. It supports existing CFML libraries if you want that. It has tooling, like an IDE and a debugger from day 0 or from day minus 60, really. It innovates on a language and a platform level, and particularly around stuff like Java interop, modules and packages, getting rid of certain ancient and deprecated ways to write CFML code by actually making a conscious choice of which functions make it into BoxLang with a very clear communicated plan of what will be released and what built-in functions are there, what tags are going to be there. It has really nice support for async and futures. And it's using a whole bunch of modern JVM features and JVM technology. And it has also syntactic sugar. You know, like when you look at like this example at the top, I just am using a Java lang string as a string object, and then you can just call a Java function pretty much natively as you would call a Cold Fusion function on that object. You can do exactly the same thing in ACF and in Lucy in different ways, but the syntax here is just elegant and quick. It's a very little thing, but it's almost to that level of like, there is a problem, and Kotlin had seen that problem for Java, and here BoxLang has seen certain problems like, you know, how to interact with Java, for example, in previous CFML. Here's a nice, cool way of doing it much, much better. And when you look at like the BoxLang documentation or try out things, you'll find a lot of these little syntactic sugar pieces. Next question is though, will it stick? So what's going to happen with BoxLang in the future? So will it be a success? I mean, I obviously don't know because I can't read like the future. But when I take a quick sidestep to Kotlin from earlier, why was Kotlin invented by JetBrains? What drives people to come up with a new language? The reason that JetBrains had was they are building IDEs. They're building IntelliJ and WebStorm and like RubyMine and whatever they're called, right? And these languages were written in Java back in the day. And they realized Java was not a productive language for them because they had to write so much boilerplate code to build their own products. They wanted to use something else. So they, back in the late 2000s and early 2010s, they looked into other languages, for example, Scala, and found they didn't like anything, and nothing really fit the requirements that they had. So, you know, tech company as they are, they said, okay, let's build our own language. What would a JVM language look like if we designed it for our purpose? And that is what Kotlin became, basically, right? So it's a very niche language that company came up with for their own use. And then a few years down the track, from 2010 or 29 onwards, all of a sudden Kotlin became a thing around 2015, 2016. And that had nothing to do with JetBrains or with the intention of what this language was supposed to solve, like being a more productive language for IDE development. What it actually ended up being is it became a success due to Android for all bizarre reasons. In 2015 and 2016, people in the Android community started to figure out like, well, Java is not really cutting it. It's so much boilerplate. If I want to write a class, I have 700 fields and like getters and setters, and it's like a pain in the butt, basically. And Kotlin offered a solution, and Kotlin was the language of alternative choice, pretty much, for building Android apps. So we started, and I was part of that in 2016, we started hacking the Android SDK so that we could build apps for Android in Kotlin instead of Java, which was at the time not supported. And the outcome was that in 2018 or 2019, Google had no choice but to say, yeah, fine, we make it official. Okay, right? They wanted to stick with Java. No one at Google really wanted to move to Kotlin, but there was just this massive wave of people saying like, we don't want to code in Java anymore. We want to code in Kotlin, and we want to have support in the Android SDK for Kotlin. So coming back to the question of like, will BoxLang be a success, right? We should all want BoxLang to become successful because we are a small community, right? The last thing we want is community splits and fractures and all that kind of stuff. We want collaboration, and we want for BoxLang to be adopted ideally by other people, right? Because while BoxLang can be a replacement for ACF or Lucy, which is cool if you want to, that's not really all it should be from my point of view. It should be visible, it should be pushed to Java developers, to Kotlin developers, to web developers in generally, as a way to build web applications, which is kind of the core thing, essentially, from my point of view for now, on the JVM in a modern way, right? And I mean, this is what Ortus has been pushing for, and what Ortus has also said quite clearly. This is not necessarily about like taking over ACF and taking over Lucy, but it needs to be marketed to Java folks, for example, and to other people, and to grow the community. The problem with that is, I'm not saying this is not possible, it's lots of work for a small team, and it needs lots of luck. And that draws the bow back to this Kotlin situation, right? Like Kotlin was a tiny language. They talked about Kotlin at like the annual JVM summit. And sheer luck that enough people in the Android community picked it up and liked it made it a success. And sometimes that's all it needs. It needs a little spark, and all of a sudden something becomes big, right? And no one obviously knows that BoxLang will get that spark at some point or not. We don't really know. But it is, at least from my point of view, worthwhile the effort of trying. And that's what I feel the Ortus folks have committed to, trying, make a platform that innovates and make a platform that creates also some more competition in the CFML world. Because competition between CFML engines is actually a good thing. So we have two, so we have three now, and we have a third one, that third one pushing the envelope further, which is really nice. From a technical point of view, obviously BoxLang is more than just a language, right? You have the runtime, you have the services, you've got the tooling and all that stuff around it, which, is really cool. It's not part of a core language, but it gives people the opportunity to start right away. It's like you get BoxLang and you get a few things installed and you can get going. And that is kind of almost unusual to some extent these days as well. And then there's the transpiling approach, and that allows stuff like plans for Android and iOS and WebAssembly. I have no idea personally how this is going to look like, and if this will be an avenue that people will use. But at least the Android bit kind of lends itself to BoxLang from a language point of view and from a JVM point of view. And for people who have never done Android, on Android devices, you don't have a JVM as such. You have like a runtime, which is called the Dalvik runtime. But it's very similar. So you target a very similar platform, basically. And I think it's quite exciting to have a look at how this is going to go in the future, right? Will it be successful and groundbreaking? I don't know. But I do know that there is a team of people who are really willing to try and who have pushed the envelope for CFML developers in the past. So I'm all for giving them the benefit of the doubt and supporting these endeavors, because they will make it better for everyone. And with that, we're done. Here are my contact details, and if no one has questions, you're all allowed to go to lunch. I hope you enjoyed the last 45 minutes or so. So are there any questions? No. That is fine. Go.